Welcome to this first video on my Arduino Uno. It's the first one in which I use the Arduino Uno just like that, not in combination of anything else. And one of the reasons that I do this is because I want to test it, since in past experiments in combination with for example, Arduino Mega 2560, something went wrong, and that going wrong was especially the mechatronics part. This is made by fischertechnik, not uncommon to my experience, experiments as well, but it stopped running. And the purpose of this experiment with the Uno breadboard with electronics and some fischertechnik is to see why it stopped running, if I can get it done. So what have I put on it? Well, I have a pot meter which is connected to mass and power, ground and power, probe to oscilloscope, and it gets its power from the Uno. Then an LED which shows just some result from pulses modulation to power it up. Here also an LED to power it up, and a transistor circuit which is supposed to drive this motor with chain. And to this combined is a switch which has to deliver a signal, and that should do it. As you can see, it doesn't run. So the question is, why doesn't it run? Is there no signal? Well, currently, looking at this probe and the oscilloscope, it gives a signal, but not the one I like to see. And it's all hooked up. So if I compare this to other means that this should work, I am quickly looking at the ways they are hooked up, and then I see I make a slight mistake. This one should not be here, it should be here. And even then it doesn't work. Although there are very nice signals right now. The question is, why doesn't it work? It's when it's even hooked up to the base of the transistor, which gives the undistorted signal. This is the way it should be, to the common. And even now it gets a signal that shows it doesn't work. So despite having it now standalone, things are not quite alright. And this signal goes straight to port 6, or port 6. So I may have to put it into another port. So with this first experiment not working, I have to look at the code, how to do this. So let's take a look. So right now another camera view of the breadboard. with mechatronics, so I should better put it like this. Then you see everything. Oscilloscope. Yellow wire right here. Yellow signal right here. So just the voltage. Then the blue one right here at the base of the transistor. Purple is measuring the signal coming from the switch here. So I will assume that that is, let's press the switch for a moment. That's typical. So where does it go? This one goes right here, straight to the input. So yes, this is the signal. This goes to ground, and the remaining in the middle goes to the power, and that is the configuration that I need. So why does it do anything? That's a vague signal. There should be power. Let's compare this for a moment to the other experiments that I have. Yes, it's the same. So that's not good. And the last one right here is something that just goes on and off. Anyway, in the past I made a version 1 of the code for the Arduino Uno, including AVR C and including SPI, Serial Peripheral Interface protocol. I removed it all. So what is left is this code. Logical? Probably not. So this is still the old schematics, and I will save this as being 2. Then I can remove all this, because in the present experiment it makes no sense. Go. Save. So what is left? A switch to the motor. I checked it. It is to a 0. Then 1 is going to ground. Check. 2 is going to the signal. Check. 3 is not connected, it's going to power. So this is wrong. This should go how to put it nicely. Okay, let's do it here. This goes to power. This way it should work, no doubt. Then from 5 is the yellow wire to an LED, just works. Then the signal, yeah, that was I need another signal, which is the signal to the transistor, and that is 5 and 6. Do they both go to the transistor? I don't think so. So looking here, I see this white one going to the transistor, which is 6. Where is 5 going? Right there. So this doesn't make sense right now. This is not good. Okay, so this wire has to go for now. It's going to another LED. I have 2 LEDs. So if this is 1 and this is 2, the 5 should be 1. Let's make this 5. Although 9 is another LED. I leave this intact. Oh yeah, this is 5. Oh wait, okay. Okay, let's do it very simple. Set and done, because this is 5. A1 is not connected. And this should, or is it? Yeah, oh yes, it is connected. A1 is connected. Physically, and that's it. So, enough checking for this one. Now the code has to work. So that's going to be a challenge. So I have to remove some remains of old stuff. The 5 is still there, although it's no longer AVR C controlled, never was. It is just a PWM LED. Pulse width modulated. These are valid. Process it. No, gone. This is also gone. Value for motor. I don't know anymore. Timers can go. Those were experiments I no longer use. So, output, pin 13, nope. Oh, that's a nice one. If I don't declare outputs, then nothing will work. So, output has to be 5. Output has to be 6. Yeah, if I don't declare that, nothing is going to work. 9 is an output, so that is correct, but let's put things into sequence. That means that this one has to be there too, and this is 6, which is an output to the switch. Yes, to the motor actually. Without this, it's not going to work. Simple as that. This is Alt, go. So, digital out, pin 5. Is that true? Yes, so actually I have to put 5 in there as well. Do I have input? Yes, I do have input, because A1 A0 and A1 are inputs. No, and this is not. Wait a second. Am I doing this correctly? Should I say A0 is output? That may be a point. So is input, by the way. So let's check this. If it doesn't work, I have to change. I have to remove every digital in and out. So this should be then in for now. Let's see if this works. If it works. So the present code with all I2C and SPI goes from, oh wait, I have to of course select the correct, where is the Uno? Oh, here. And Uno, but I have to do one more thing, and that is claim ownership of the interface. This one, because this is the interface connected to the Uno. Without having ownership, it won't work. I won't be able to upload. So now I can go. See, that is what I mean. Was not declared. Okay. That means that this one is 6, 9, alright, go. But does it change anything? Actually, it should. So have a better look at it. This LED is working. This LED, not so much. It's coming from 9. What is 9 doing? Am I sending something out of 9? Yeah, here. But it is an if statement. And it's not doing anything. So, oh yeah, it is, because I say process it is true, but how what is sensor value doing? That's a good one. Let's open the serial monitor. Output value. And what is sensor value doing? Over 1/3, it's over 100. Clearly over 100. And process it is also there. Oh, digital output is low. Aha, yeah, then it doesn't do anything. So let me change this to high. Then I can see it is doing anything. Go for it. I don't see it. And this one is clearly from 9. How many probes do I have? Alright, this is certainly working. Then I have to change this one. Alright. Okay, this is clearly a plus. However, LED is doing nothing. And this one isn't doing anything either. So this indicates a real problem. And this motor, oops, goes out too easily. Yes, it is a thin wire, but it was in anyway. So what am I looking at? Something that doesn't work. Except for this one. And I can also check, of course, taking a screwdriver for the value of the potmeter. Where's the screwdriver if you need one? Anyway, this is not entirely going to plan. Okay, so to make things more clear, sensor value is the switch, which means attached to where these wires are attached to. And if I press it, and that's the weird thing, the switch is in this case either 1 or 0. So I should check it for Boolean. So if I press it manually, what does sensor value say? 0. So that doesn't make any sense. Alright. Let me take the blue one, which was here. Let me put it to the power. In some way. Let me put it like this, then you can see something. So this is power. Okay. Oh, yeah, right. Classic mistake. A very classic mistake. I have to wire everything through, which hasn't happened yet. Very classic mistake. No wonder it doesn't work. Okay. Some more jump wires and see if it works then. Ouch. Alright, now I've put some wires here and there. So now once again, if I put this camera more here, do I measure some nice wiring? Not really. Plus should read some now. Okay, this is not good. Because plus doesn't read anything. Oh, this is plus. Yes, right, this is the plus. And this is minus, so that's correct. Now measuring on the signal, but the signal doesn't measure anything. So although this is alright now in wiring and in connecting plus with plus, etc., it's still not alright. And one thing that's not alright is this as well. So right here, this should be high, and it's not. And it is coming from where? Ah, it's out. That's why. See? Now it works. Yes, that's one thing. So this wire should be here. Measuring something, and now it does, but still the motor doesn't run, so that's weird. Okay, now it does, and it just did. The question is, why does it? Why does it start? Why does it stop? Ah, now I found the culprit. It's a mechanical issue, but then it doesn't touch the switch. No, okay. So I need to fix this a bit. And now it does work. Although very slowly, it runs. And is there a signal being measured? Mind this line. It's not being measured. Alright. Anyway, this must be the end of the of this episode. So I have unfinished business left with this one. Anyway, wrapping up. Oh, that was once again a video with some mistakes, oopses, and well, so at least some positive results, although with questions as well, because why is this transistor circuit working with a normal signal and not via the diode side? That's not good. I can put this one on it, and that gives a distorted signal again. So anyway, thanks for watching. If you like this video, no matter the errors, mistakes and oopses, then please subscribe to my channel for lots of different and other experiments involving electronics, mechatronics and robotics. Give a thumbs up, leave a comment or suggestion. You can also follow me via Twitter. Please retweet, like it, leave a comment. You can also follow me via Instagram. Please like it, leave a comment. You can support my experiments by making a small donation. And you can also become a patron and have your name mentioned as a supporter. And this is going to be continued. So thanks for watching. Oh, by the way, everything is listed under this video, website and Instagram and Twitter tags. Thanks for watching and bye bye.